In today's lesson, we will be integrating using U substitution. At first, it's going to feel kind of strange, but as we do a few examples, I think you will catch on. We're going to start with some indefinite integrals, and we'll end with some definite integrals. So in the first example, we are going to find the antiderivative of x times x squared plus 3 to the 5th power. Now, what I want you to think about is pretend that instead of taking the antiderivative, we're just taking the derivative. How do you take the derivative of this? Yes, ignore the fact that yes, it would be product rule, but this part right here would be chain rule. If you see chain rule, something that looks like chain rule, when we take the antiderivative, we will be doing U substitution. Okay, so this might feel a little weird, but just kind of go with it. So I'm going to take the inner part, kind of where like the inner part of like the chain rule would be, and I'm going to write that I'm going to write that as U equals x squared plus 3. So it's like I'm simplifying this down a little bit. So I'll have the integral of x times just U to the 5th. So that's a little bit easier. But now, instead of dx, I'm going to write what dx equals by taking the derivative of this. Du with respect to x, dx, is equal to, take the derivative of the right side, is 2x. And then I'm going to solve for dx. So du equals 2x dx, and then you would divide. So dx equals du divided by 2x. So up here, instead of the dx, I'm going to write du over 2x. So by doing that, these x's cancel, and this is like a 1/2 I can bring out in front. So I can rewrite this as 1/2 times the integral of u to the 5th du. And now the antiderivative of that is 1/2 times u to the 6th divided by 6 plus c. And now once you've done that, we take the u out and place back in what u equals. So this is now going to be, so instead of u, it's x squared plus 3, and that's to the power of 6, and it's now over 12, and don't ever forget that plus c. So a quick recap, you kind of take the inside. If it was chain rule, it'd be kind of like the inside of the chain rule. It's u, so we replace that in here. And then we're taking this derivative and solving for dx, putting this in, and oftentimes something cancels. And that is helpful. And then after something cancels, antiderivative, plug u back in. All right, next one. The integral of 3 times sine of 3x minus 1 dx. So I'm going to take the kind of inside part of this function. I'm going to say u equals 3x minus 1. So then I have the integral of 3 times sine u. And then now instead of dx, we're going to change this by taking the derivative here. Du over dx equals, the derivative of the right side is just 3. Solve for dx. Du over 3. So times du over 3. And now these 3's cancel. So now I just have the integral of sine u du, and this equals negative cosine of u plus c. Substitute that u back in, so negative cosine of 3x minus 1 plus c. All right, third example, the integral of x times secant squared of x squared dx. So go on the inside here, I'm going to have that u equals x squared. And I'm going to go right away, and let's just take the derivative of this. Du dx equals 2x. And after you do this a bunch, you kind of get the hang of it. So we've got dx is going to be du divided by 2x. And this is the integral x times secant squared of u times, instead of dx, we're going to put this as du over 2x. The x's cancel, and then this is like a 1/2 I can have out in front. So secant squared u du, what is the antiderivative of secant squared? This is equal to 1/2 times tan of u plus c, and then bring the u back in. 1/2 tan of x squared plus c. Okay, let's do one more indefinite integral, and then we will do 2 definite integrals. This one, integral of tan x dx. So this one is not super intuitive. It's a little bit different than the ones we were doing. So first thing we're going to do is rewrite tan as sine over cosine. And then I'm going to make u equal cosine x. And then if I take the derivative of that, du over dx equals negative sine x. So dx equals du over negative sine x. So back here, let's do sine x over u. And then instead of dx, I have du over negative sine x. So what happens, these cancel out, and then this negative can come out in front. So negative, and then the integral of 1 over u du. So to take the antiderivative of 1 over u, so I have negative, and that is the natural log of the absolute value of u plus c, and now u is cosine x. So negative natural log of the absolute value of cosine x plus c is the antiderivative of tan. All right, now for a definite integral. So the integral 0 to 1. So I'm finding the area under the curve from 0 to 1 of this function, x to the third times 2x to the fourth plus 1 squared dx. So starting with this inside, I will make this u. U equals 2x to the fourth plus 1. And if I take the derivative, du over dx is equal to 8x to the third. So over here, let's change everything. 0 to 1 of x to the third times u squared. And, oh, I still have to solve for dx over here. Dx is equal to du over 8x to the third. So this is now du over 8x to the third. So the x to the thirds are going to cancel. A 1/8 can come out in front. And I'm going to do one thing here is we are going to change the intervals of 0 to 1 using u. And by doing this, we will not have to substitute u back in. So let's just go through that. Okay, let's bring the 1/8 out in front. I have got the integral. I'm not going to put my intervals on there yet. U squared du. But what we can do is just plug in 1 into u. So that would be 3. And then plug in 0 into u. That would be 1. So simply by changing these intervals, I don't have to plug this back in. So when I do the antiderivative, I've got 1/8 u to the third over 3, and we're going to evaluate that from 1 to 3. So this will equal, plug in 3, so 3 to the third over 24 minus 1 to the third over 24. So 27 minus 1, 26 24ths, which will simplify to 13 12ths. All right, our very last example, another definite integral. So the integral from 0 to 1 of e to the negative 3x dx. So first thing, let's define u. U equals, this time the exponent, negative 3x. We need to take the derivative, du over dx equals negative 3. So dx equals du over negative 3. Okay, let's substitute our stuff in. So the integral from 0 to 1 of e to the u, and then du over negative 3. So nothing's going to cancel, but I can bring negative 1/3 out in front. So negative 1/3, and I'm going to change the intervals here. E to the u du. So if we change these intervals using u, we don't have to substitute u back in. So let's plug in 1, so negative 3, and plug in 0, we have 0. Okay, now the antiderivative of e to the u is just e to the u. So negative 1/3 e to the u, and we're going to evaluate it 0 to negative 3. So this equals negative 1/3 e to the power of negative 3 minus negative 1/3 e to the power of 0. Let's simplify that a little bit. All right, so this would be negative 1 over 3e to the third plus 1/3. And we're going to call that good enough. So there's your full lesson on integrating using u substitution. I think it can be pretty intimidating, but once you get the hang of it, I think it's actually kind of fun. So there it is. Good luck with your lesson.